So recently my garage door opener started malfunctioning and I spent about a week trying to track down the problem, tore the thing apart, basically traced all the leads on the circuit board, tested relays, checked capacitors, checked everything visually, and I was completely stumped to the point where I was shopping for a new garage door opener. I actually got kind of excited because I saw Ryobi makes one that is awesome. I later found out that they no longer sell it, however you can find them on eBay and various places. Apparently there was a lawsuit with Chamberlain, who's like basically makes all the other garage door openers on the market. They sued Ryobi and Ryobi was forced to stop selling it, which is disappointing and is basically stifling innovation in the garage door industry. And a little bit bitter about that. However, I did fix my garage door opener. I believe this unit, it's a Craftsman garage door opener that I bought from Sears. However, I believe it was made by Chamberlain because I think they make just about all the garage door openers out there for various companies. So this fix will apply to like a Sears Craftsman garage door opener, but probably Chamberlain as well and other makes and models because I think they use all the same parts. And from researching online, this seems like a pretty common problem. However, it manifests itself in different ways. In my particular case, it wasn't visually obvious what was going on, and I'll get into that and show you how to test for that in a moment. But real quick, I basically learned overnight. I got a master's degree in garage door openers. It's kind of funny. I called Sears General Support, and I had somebody try to sell me vinyl siding, an air conditioner for my house, a roof, a kitchen or a bathroom remodel, but they couldn't do anything in terms of helping me with my garage door opener. They couldn't even schedule somebody to come out and look at it or tell me how much it would cost for somebody to come out and look at it. I eventually did find a number, a Craftsman tech support number, where I did talk to somebody who did try to help, and they have generally really good customer service. However, she told me at this point I know more about garage door openers than she does, and actually kind of jokingly offered me a job. So I'm going to give you just a quick overview. I've got a little bit more of an appreciation for how much is going on with the garage door opener. Primarily, a lot of this has to do with safety, but there are a lot of inputs going into this. So just really quickly, kind of here in the center, I drew a box. This is your garage door opener. From an input standpoint, I marked them all in red. You have your basic wall switch, which is wired in my case. I think on the newer ones, it's more likely wireless, but the older ones, it's wired. You also have this little brake beam infrared sensors here to detect if anything is under the door when it's shutting. Those are wired in as well. And then you have on, in my case, the right side of the garage door opener, if you're standing at the garage door opening, is the travel limit adjustment screws. So there's an up travel limit, down travel limit adjustment. And then on the left side of the garage door opener are the force opening and closing force adjustment screws. And then right here I marked, this is just a little antenna. So you have an antenna, which is basically taking inputs from like a garage keypad, your car garage door openers, etc. And then the last input, which surprised me, is there's an RPM or a speed sensor on the motor itself. So your basically logic board is monitoring the garage door speed, or not the speed of the garage door, the speed of the motor itself. And I believe that's how it's actually doing the force settings, because basically it's, in my case anyway, it's an AC motor. It has one speed. There's not really force control, but what it's doing is it's looking at the speed and it's seeing, hey, it's slowing down, which must mean there's a heavier load on it, and depending on where you set these screws, that threshold of when it stops or reverses changes. So that's a real quick overview of the inputs of the garage door opener. So in my case, the problem was when I shut the garage door, it would go all the way down, completely closed, and then it would pause for a brief second, and then it would reverse and open all the way up again. So basically, it wouldn't stay down. Now, when this happened, it started happening when there were like radical temperature changes, like 50, 60 degrees from one day to another. So I thought, okay, just a little setting, adjust the screws on the right side, the travel limit screws for the down, and it seemed to fix it the first couple times. Then all of a sudden it stopped fixing it, and I turned it, nothing happened, still went down, reversed, turned it some more, turned it some more. It got to the point where I turned it like multiple turns, and then all of a sudden it would go down, it would close like 2 feet off the ground. So clearly the travel limit adjustment wasn't working properly, and then all of a sudden it would work. So it was intermittent, which made it really difficult to troubleshoot. So I did some research online, and the most common cause of that particular problem is related to the wires on this switch assembly. So there are 3 wires coming from it, one for the up limit, one for the down limit, and then like a central ground common wire. And if any of those come off or are damaged, it'll stop working properly or stop working altogether. So basically what was happening is the down limit wasn't registering. So the garage door would close until it got all the way closed, but then it would continue to try to close, and it would trigger the safety reverse, because the logic board would see that the motor speed went down to 0, but it was still trying to close, so it would reverse and go back up. I'm not sure what would happen on the upper limit if it wasn't working properly. It went all the way up and it stopped. I have a feeling it would probably just stop in place. It wouldn't reverse and go back down, but I'm not sure. I did not test that. So from a troubleshooting standpoint, remove the covers. So remove the side cover and then remove the metal center kind of clamshell. And I left the other side cover with the force adjustment switches and all the wires, the inputs coming to it, on for the time being, because you can see everything you need to in terms of the travel limit mechanism on the right side of the machine. So did a visual inspection, open and close the door while I was watching, made sure everything looked fine, and it did. There were no wires disconnected. You need to just follow the little leads up. It goes around behind the motor assembly to the logic board, plugs in. Just make sure there's not a break. I did find that my wires were resting on the gear itself. They were covered in grease. So I thought at first maybe there was a problem with the wires. They had gotten frayed or broken from just friction there, but that wasn't the case. It's just a terrible design. So double check that. Make sure that they're not actually resting on any moving parts, because that's not particularly good. Oh, a note, definitely something to, just a disclaimer here. If you're opening this up, be careful, because there are hot leads inside of the machine going to the light bulbs, various other things. There's some low voltage stuff, but there's also some higher voltage stuff. So don't stick your hand in there. There's also moving parts. I mean, the thing opens and closes garage doors. There's gears, there are mechanical things that move. You could probably hurt yourself if you're not careful. So when you are poking around in there, keep your hands clear, pay attention to what you're doing, stay focused, and just be careful. If you need to work or unhook wires on the inside, unplug the machine first. There's also a really big capacitor if it's an AC motor, which in my case it was, and it probably is in a lot of cases. So don't assume that everything's safe even if you unplug it. That capacitor might have a residual charge, so don't just grab it with your bare hands or touch the leads unless you're just being very careful. So wear gloves in that case maybe, but just be careful in general, even if it's unplugged. Okay, you never know, it could have tension on it. There's a million things that could go wrong. So just take your time, be careful. In general, this switch here, you can see it and you can work with it without having to get near any moving parts or anything that might have higher voltage, but just be careful. So if you inspect this switch or this mechanism and the wires are intact, they're not falling off, they haven't broken, it seems like they have a good connection, the next thing to do is to ensure that there's not an internal break. And that's what essentially it turned out to be for me, is inside of the insulation, the wires had just started to break apart and it was intermittent. So as this little trolley traveled back and forth, it was pulling and stretching this wire and bending it, and that bend had become weak over time. So as it got towards the lower limit, or the close limit on the switch, it was pulling that wire out, and all of a sudden it would lose its connectivity, and it would no longer register when it touched the lower limit switch. It would keep trying to close. However, when it was in the up position, it was making a connection. So it took me a while to realize this, and ultimately the test that I used to determine that there was a wiring problem in that harness was I hooked a lead to the central kind of the ground wire, and then the close limit wire, and I hooked those to my voltmeter, my multimeter, turned it to DC. I could see that there was 5 volts there, but then as the garage door closed, that would start to fluctuate and it would drop down. Sometimes it's 3, 2, 0. It would be all over the place, and that was basically the problem right there. So there was a problem with one of those wires. To determine which one, I removed the lead from the lower limit switch and moved it over to the upper limit switch. So then I had basically reading the difference between the center one on the trolley and the upper limit switch. and I saw the same thing. So that basically told me that it was the common one in between them that was causing the issue, and it made perfect sense because that's the one that moves. So I removed that wiring harness. It basically runs from the 3 wires. There's a yellow, brown, and gray, I believe, but you'll see in the video what they are. They run from this switch around the back of the machine up past the main kind of drive gear for the opener. In this case, they were just laying on that, which is ridiculous. They come over to the logic board where the yellow and the brown one went into a plug into the logic board. The gray one had a little loop, and then it came up and around and went to the plug on the motor speed sensor where it terminated, but then a new gray one started from a different pin on the plug and went back to the logic board. So basically that wiring harness has 2 white plugs and then 3 wires that come off of them that have these little spade connectors that plug onto this switch. Once I did remove the wiring harness, I was able to use my multimeter and check for continuity and just move it a little bit, and I could clearly see that there was an issue because it was breaking continuity just with a little bit of movement on the table. I took a video of that as well. Now I did look at the parts diagram, and the switch does not include the wiring harness. There is a wiring harness listed. However, I contacted Sears Parts Direct, and they could not tell me if the wiring harness or if that part number was the wiring harness I actually needed, because it wasn't pictured in their parts diagram. There wasn't a picture of the harness itself. There really wasn't a description. Basically, they list 2 wiring harnesses, one high voltage, one non. I'm assuming it's the non-high voltage wiring harness, but they couldn't confirm it, so I decided to just repair it myself rather than order one. They did try to, once again, schedule somebody to come out and look at it, and at that point I just told them no thanks. So basically I repaired the wiring harness. I just replaced that gray wire with a piece of 22 gauge standard kind of braided wire. I went all the way to the plug that goes on the speed sensor for the motor. Got within an inch or 2 of there, cut it, soldered a new one on, put some shrink tube around it, and then ran it back the same route, zip tying it all the way. And then I did zip tie it up a little bit higher so it wasn't resting on the gear for the motor. Brought it back down here, and then I left kind of a bigger loop on this side. I figured bigger loop, it'll kind of spread out the stress of the movement, and hopefully it'll last more than 9 or 10 years this time, and I'll never have to mess with it again. We will see. One thing to keep in mind, if you do leave a bigger loop like I did, when you put this end piece back on, just pay special attention to how it's fitting on and make sure you're not going to pinch that wire at all, and kind of like, you know, run the garage door up and down a couple times, make sure it's not going to get pulled off or interfere with the movement of the assembly or anything like that, and you should be good to go. Feel free to post any questions you have in the comments section. I appreciate it if you like and subscribe. I hope this video helps you out. I hope it saves you $150. You don't have to go out and buy a new garage door opener. You just replace a wire and you're good to go. That is it. Until next time. Quick note here, when you're reassembling, there's actually 3 different types of screws that hold kind of the outer housing and the various pieces on. There is like a machine screw with a washer, machine screw that doesn't have a washer, and then more of like a coarse pointed type screw. So I did not take too much note about which ones went where, but I am deducing and kind of piecing it together. So basically, I think the machine screw with the washer holds the plastic outer shells on at the top. The machine screw without a washer holds the actual the metal housing on at the top. And then the screw here with the point and more of the coarse thread goes through the plastic piece on the lower holes that actually correspond with the holes at the bottom here on the metal outer housing. So the more coarse ones with the point go through these little plastic retainers. The machine screws without the washer go through this metal housing here. And I'm guessing, just based on the indentations here, you can kind of see it looks like they correspond with the inside of that screw. So that's where the different screws go. I don't know that it's that big of a deal. You probably get by swapping these 2 on the right. Those guys I think are going to be specific to the lower part of the plastic pieces that go through the metal white retainers.